And we're live.
Let's go.
All right.
You say that you remind me of Freddie from iCarly.
Number 3.
Oh.
All right. Fresh packet.
Ooh, wait,
Page 1.
you want to blasting.
Teaching the same thing again.
I need a hobby. I need a hobby. Instead of listening to Hamilton all the time. It's okay.
Oh man.
Bruh.
Alexander
I
Hamilton.
honestly,
Bruh.
I can
The
figure, but
historical
I have
figure.
no idea other than the person. I don't know.
All right. For those of you that are still here,
Yes.
who wants to do Zayden? We're just gonna go insane together. I will outlast you. All right. Yeah. In my defense, I was here longer than you, and I was here yesterday, and I'll be here tomorrow and the next day.
To be fair, I'm not leaving, and you can't
Oh,
snitch on me
God.
because that's against your rules.
That's right. Snitches get stitches.
Exactly. Try to stay.
All right. Welcome to Math After Dark. Woo! It's party time. Bow, 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 bow. All right. So, Chance, are you here for portfolio stuff, or are you here for this?
A little bit of both.
Okay, gotcha.
I mainly need to finish the portfolio, so I can turn it tomorrow.
Gotcha. So, Chance, do you want to go through this right now while I'm going through it, or do you want me to just do my thing and you tune in and out when needed?
I'll just tune in and out.
Okay,
I'll-
so
I'll be watching the YouTube videos.
Okay.
Anyways.
that's what I would do. Because right now, if you're not really paying attention 100% of the time, Nelly is going to run the show.
Shelly. I love that name.
Yeah, that's my mom's name.
Oh.
So you're going to run the show, Nelly. So do you want to see number 1?
I don't like it. I hate it. Shelly.
No.
I prefer swimming, walking, speed walking.
What if I failed the swimming final?
Be disappointed in you.
You
You never told me she's gonna drown. No.
Just don't poop in the pool and you'll be all right.
Wait, someone solved this. Were you here?
Cancel the swim final for everyone.
We were talking about Jericho pooping in the pool.
Hero, hero.
Okay, that's what I thought. They didn't know
Can't take a swim final if there's no clean pool to swim in, right?
There's a bunch of hairballs in the pool.
True.
There's a bunch of algorithm things.
I'm pretty sure this.
They're not fun.
King
You
God.
know, he
They're
told me
really
what's
not.
one of them.
Okay, one of them, you want to learn one.
Yeah, I'm pretty sure.
So, notice the
Portfolio fun times.
in this, so this is
Where are
green,
you
this
at
is orange,
right
that means
I've got like 2 days
Should I not do stuff?
there.
Oh, okay.
I just want like a quick
the orange, the
rundown, like
green
not
has
of
to
like
match up with
the
this
stuff
and
that we
the orange
took
has
the
to
test
match up
over,
with
but like this.
Great. That's why I'm here. That is exactly what I was planning on doing.
You know, sometimes
like-
you can do it like that, but
like-
it's good.
Yes.
But
Hold on, I might run a
and
page.
it doesn't do that, you gotta go.
Ooh.
Then it does that. So you just move it up, and move it back. Now,
To be honest,
side.
I just need like to page 10.
Okay, but could you prove number 1? Because that's different than what we were supposed to do before. Like, slightly different. Like, you have to back up your reasonings.
Yeah, that's what I mean. So like page 1 to number 10.
Oh, got it. Okay, I hear you. I hear you now. I hear you.
Stop! You can't just turn it on.
Okay. Here we go. All right.
Doing it live.
We are doing it live. So this is what's given to us, so I'm not going to make you write anything given. That's all good. We're just going to say this is given. Whoop. Given that. Saving time, saving pen. That's good because we're going to use a lot of ink for the 3rd time on this with 2 more times of doing this in my future.
Can I be there for those two?
Yes. I'm not going to sneeze. I refuse. All right, so here's what I'm going to write. The idea is that this right here, -6 gets you CD. And this minus 6 gets you AB. And when I add all those up, I should get 3x minus 4. This is all segment addition postulate. So I'm going to write that this one, BD, equals, oh my god, I did this so little ago. Like, so it wasn't much. Okay. BC plus CD. And that's by segment addition postulate, SAP. You don't have to write this down because I can literally just give you those and you can, whatever works for you, okay? I just don't want you to be stressed. Okay, so then by substitution, I can write that negative x plus 1 equals BC, which is 6, plus CD, which we don't know. So I'm just going to leave it as CD. And that's by subs. Cool? Then I'm going to do some math and find out that negative x minus 5 is what CD is. Cool? So I'm going to write that in up here. Awesome. Then I'm going to do the same dumb crap, but I'm going to do it for this part. So I know that AC equals BC plus AB. I'm on autopilot right now. This is amazing. I'm not even thinking. There's no thought going into my brain right now. Absolutely none. I can multitask and do this. This is no big deal. I'm not even looking what pen I'm grabbing. How is this possible? How is it possible to grab the right pen without looking? This is amazing. Okay. I know. So then I do math, and I'm going to get x plus 10 is what AB is. Okay? Then, by segment addition postulate, I'm going to say that AB plus BC plus negative x minus 5. I'm going to wrap that in, oh wait, CD equals, what's the bottom color should I do? Oh, let's do pink. Let's do pank. That's AD. That's by segment addition postulate. Cool? Then I'm going to substitute their values. X plus 10. 6. Negative x minus 5. 3x minus 4. And that's by subs. Then I'm going to do math. X's go away. That gets me 16 minus 5, which is 11. I'm going to add 4 and divide by 3. So I get that. X equals 5. Now I need to find AB and prove it's 15. So I write AB equals x plus 10. That was something we found out earlier, that AB is x plus 10. Yep, right here. Right, so I'm using that from earlier. And I'm going to plug in x equals 5 by substitution. So therefore, that's by subs. So therefore, AB equals 15. Swag box. That's it. How do you feel?
Great.
If we need to do the rundown, I could just use the old packet maybe and just talk you through the idea. Right? Would that be good? Okay. Which one's the newer one? I like the newer one better. I think it's this one. Yeah, it's this one. Okay. PFAG. So, here's the idea. Draw a coordinate plane if you want, or imagine one. That means this is x1, y1. That's x2, y1 here. And that's x1, y2 here. The horizontal distance is b, and that's going to be x2 minus x1. Vertical distance is a. Pythagorean theorem. A, B, C. We know what A is. Plug it in. We know what B is. Plug it in. Root. There it is. Again, the idea is we have the vertical distance here, the horizontal distance there, and it's vertical first because in this diagram, A is first, right? Okay, good. Vertical distance, horizontal distance gets us this. The idea is that from here to here, there's two components, a vertical part and a horizontal part that's happening. And when they both happen at the same time, you get a diagonal, right? It's like a robot moving both horizontally and vertically at the same time. It produces a diagonal, right? And so we break it apart into those two individual parts because we can figure that out a lot easier. And then do Pythag to figure out this. That's the idea. All right, this one. So 1-to-1 ratio means we cut it in half. A 2-to-2 ratio would be the same thing because it's both on the same side, right? It's the same amount on each side. Midpoint formula is average of the x's, average of the y's. Because there's 2 x's there and 2 y's there, we divide by 2. Then we plug in our stuff. x2 is first. Y2 is first. The reason for this is because order matters sometimes. In this problem it doesn't, but still, stick with it. So we plug in 1 for x2 and 5 for x1. We add them together and divide by 2, 3. This one, -7 plus 1. That's -6 divided by 2, and we get -2. That wasn't right. -7 plus 3 is a -4. We divide by 2 and get -2. So that's the midpoint. Separate problem, they asked for the distance. So I broke it down into a right triangle, 4 and 10. Square them, add them, root them. That's the distance. Hi, Chance. You're with us now. Want me to slow things down?
No, it's okay.
You sure?
I just went over this like last week.
That's right. You could also use distance formula. But remember, distance formula is just the first part, is figuring out how long this is with math instead of counting, right? If I'm on 1 and I'm on 5, I'm 4 apart, right? That's all it's saying. If we can count, we should count. Otherwise, we can do math, right? Plug in 1 for this guy's x and 5 for this guy's x and figure it out. Or you could just draw your triangle. Cool. How you feel, Chance? Yeah? Okay. 6 is the same thing, so I'm going to skip the distance part, and I'm just going to talk about this. A 3-to-8 ratio is 3 to 5. Right? Because 3 on this side, 5 on that side. Order matters because we're starting on A and going towards B. If we went on B and towards A, it would flip these guys, right? 3/8 would be here. So order matters. So that means you have to have your x2 and y2 first. That's important. 3 to 5 ratio means 3 and 5 up top, 8 pieces total. Then I plug in x2, which is 1, and I plug in x1, which is -7 here. When I do that, I get -32. Trust me on that. Divided by 8, I get -4. Same thing here, but just with the y's. y2 first. Then y1 next, we get this. That's the point that's 3/8 of the way between A and B. Cool? If you'd flipped your x's and y's, if you'd done x1 and x2 here, you would have gotten the point that's 3/8 of the way between B and A, which would be right here, as if you'd started on B and walked towards A. You doing okay, Chance? All right, cool. All right, right ahead. That's that on that. The beginning is the most difficult part. It really is. Midpoint formula. Okay, so normally they give you 2 points and you find the middle, right? This one they're saying they give you one of the points and the middle. You got to find the other one, right? So here's my midpoint formula. Average of the x's, average of the y's. Midpoint's what they gave us. One of the endpoints they gave us, so I plugged it in. The other one I'm looking for, right? So now it's this guy equals 1. So I times by 2 and add 3 to get x on its own. So I times by 2 and I get 2. I add 3 and I get 5. Here, I'm going to times by 2 and add 2. Well, when I times by 2, 5 divided by 2 times 2 is just 5, right? Because 5 divided by 2 times 2, that's 2 divided by 2, which is 1, times 5 is 5. With me? For real? Okay. And then I add 2, 7. So 5 from this one. After adding 2, I get 7 here. So 5, 7 is what it is. Other interesting way of thinking about this, -3 to 1. Right, is what I'm starting on. So here's -3 in the x direction. I end up on 1 for the midpoint, right? How far did I go? I traveled how much? 4. So I should travel 4 to get to here, right? Vertically speaking, I'm on -2 and I went up to 5 halves. Trust me on that, that's adding 4.5. If I add 4.5 again, I get 7. 4.5 to 2.5. So that's a quick shortcut, right? You need to show your work, but you can check your work better now, right? Again, it's halfway. So if we go from -3 to 1, we went 4, right? So we should go 4 again for the x part. 4 more is 5. Okay. Naming an angle. Map PAM 5A. A is the vertex, so it always goes in the middle. Map PAM angle 5, angle A. 2 rays, AM going in that direction, AP going in that direction. The ray symbol is the arrow, right? Cool. Definitions. Angle A is acute if it's between 0 and 90, right? If it's exactly 90, it's a right angle. If it's between 90 and 180, it's obtuse. Right? Now the key is, notice there's no equal sign underneath here, because if it was 90, it'd be a right angle, right? So these have to be open, no lines underneath, okay? A is 180, then it's a straight angle. If it's between 180 and 360, it's reflex. That's the like hyperextension one, right? If it's exactly 360, it's a revolution, right? Bernie Sanders. A and B added together is 90. That's going to be complementary, right? So if 2 angles add up to 90, comp. 2 angles add up to 180, sup. This one, oh God, don't look at that. I did that wrong. Look at this one. This is page 11. My bad. It should say 130 here. And then that line shouldn't be there. It should be here because it's talking about CAF, which is this angle. Here we go. This angle, and this angle all add up to CAF by angle addition postulate. The 3 little angles add up to the bigger angle, okay? Then I use substitution to switch those out. CAD is 35. This is 2x. That's 40. And this thing they said was 95. This guy. That's by substitution. I switch those values out. Then I solve, and I get x is 10. Then I say this angle, this angle, this angle, and this angle all add up to the big angle by angle addition postulate, right? The little guys make up the big guy. Then I switch out their numbers, 4x, 35, 2x, and 40 by substitution. Then I plug in x by substitution, right? And I get this. So it's 135. Done. Okay? Kind of crazy. All these guys add up to this one. 35, 2x, 40 adds up to 95. Solve for x, it's 10. All of these guys add up to this one. Plug in x, 40, 35, 20, and 40. Add them all up, I get 165. Or 135. So he's 135. Woo boy. It's a star. Abomination. All right. It's concave because, look, internal angles, there are some that are more than 180. See how those are really big internal angles? So that means it's concave. It's pointing inward, right? Caves in. Just one of those guys is enough to make it concave. This one has a lot, but you just need one. It's a decagon because it's got 10 sides, right? December is the 10th month of the year, so we call it dec. December isn't the 10th month of the year. It's the 12th month. It used to be the 10th when the Romans were in charge. That's why they call it December. And October was the 8th month of the year. It made a lot more sense. The 11th month of the year was January. The 12th month was February. New Year's was in spring. Made sense. Made sense. It made sense. Dec like decade. 10 sides, right? Cool. Pthag gets me the side lengths. Well, this one's really easy to calculate. It's 8 because you can just count it, right? This one over here is 5 in length because it's 4 and 3 for the right triangle. 4 squared, 3 squared. Add them up, root them. You get 25. Root 25 is 5. Same thing here. Same thing here. This one's 2 and 4, so 4 squared is 16. 2 squared is 4. 16 and 4 make 20, so root 20. These both are root 20s. These are all root 53s because they're 2 and 7s. 7 squared is 49. 2 squared is 4. 49 and 4 make 53. Root 53, root 53, root 53. This one's all alone because it is 1, 2, 3, 4, 5 by 3, 25, and 9, root 34. I write them all down. I add them all up. See how I have 2 root 20s? 2 root 20. See how I have 3 root 53s? 3 root 53. 1 root 34. 5, 8, 5, and 5 adds up to 23. That's the perimeter. Could I put that in a calculator and figure it out? Sure, but then I'd have a decimal that goes on forever, and like, who wants that, right? Chance, how do you feel? Yeah? All right, my man. 16, 7gon, because it doesn't have a name. It's got 7 sides. Or a septagon. This is concave, because look, over 180 right there and there. See how those are real big angles? Right? This is also concave, because it has 180 degree angle right there. Hexagon, because it's got 6 sides. This is a dodecagon. It's got 12 sides. Do meaning 2, dec meaning 10. So dodec, 12. Dodecember, everybody's favorite month. It's concave because look, over 180, over 180. So yeah, concave. They're all concave in this one. Oops. Convex is boring. 19. Prove that x is negative 7. Well, I started out with this, and I add 7. How did I add 7? Addition property. Then I divided by negative 3. Division property. Done. Chance. For this one, what properties am I have to use to solve for x? Nope, 20. It's I got you. Here, look at this. Ah? What properties am I have to use to get x on its own? 21. A, B, and C are collinear. They tell you that stuff. What A, B, and B, C, and AC are, right? We'll set them up by segment addition, right? The 2 little ones add up to the big one. Then I'll switch out their stuff, right, by subs. And then I'll solve for x. Then I'll plug it back in and get BC's equals 2. This one's the setup. D is in the interior of ABC. Boop, there it is. Then they tell us our stuff. I write it down. Those 2 angles add up to this one by segment or angle addition postulate, right? The 2 little guys add up to the big guy. Then I solve for x, and then I plug it back into here to figure out that ABD is 55. Are you guys with me? Because that's crazy if you are you? Chance? No? Okay. So check it out. For this one, the other ones were fine? Okay. So it says D is in the interior of ABC. Here's ABC. I drew it. D is in the interior. Cool?
Okay, yeah.
ABC, they tell us, is 165. They tell us this one is this. And they tell us this one is that. Okay?
Okay, yeah, that makes, yeah, okay, yeah.
This angle and that angle add up to 165 by angle addition postulate, right? AAP. Then I do math and get x. Spoilers, x is 30. And then I go back and plug it in by substitution. And I get that this is 55 like I'm supposed to. Better? Yeah. Problem this small causing a huge issue. Super easy to fix. Nice. Thanks for asking. All right, this one blew everybody's mind on the quiz. I don't know why. All right, a while ago. So they give us that JK and LM are the same. And they say prove that JL, this bit, equals KM, this bit. With me? Okay, so I write the given. These are the same. I write that they're the same. That's what they gave us. So I write that JL is this part and this part added together. Right? That's what it is. And then I write that the orange part is this part and this part added together. Now notice these are both the same color, which means they're the same thing. So I'm going to write JL equals, instead of JK, I'm going to write LM. Okay? I'm switching those 2 out because they're switch outable, right? So now I have this. Now notice these equal the exact same thing, which means they equal each other by substitution. And then I flipped them around using symmetry property to make them look the same. So chance, JL is these 2 put together, and KM is these 2 put together, right? Feeling okay with that?
Yeah.
These 2 are the same, so I took JL and I wrote LM instead of JK for it. Because they both equal the same thing, they must equal each other by substitution. And then I reversed them using symmetry to make them look exactly the same up here. In that order. Red, then orange, not orange, then red. That's all. How do you feel about that? Segment addition to get this, right? These two make up the red. These two make up the orange. Substitution to switch out JK for LM. And then substitution to switch out JL for this stuff. 26. All right, so they tell us all that stuff. I wrote it down over here. They give us all this. We're trying to prove that blue and orange are the same. So here's blue, here's orange. Here's how I'm going to get them together. See how they told us these two are the same? So I'm going to write orange and purple equal each other by substitution, right? I'm going to switch out these two, right? And then I'm going to say that purple switch out for blue. So blue is going to go here, and then I win. Because we want blue and orange together. So here's what I write. This is the same as purple, right? By substitution. I switched out the green for the purple. Then I'm going to say that purple is the same thing as blue, right? So I can switch out the purple for the blue. Then I'm going to say, flip them to get them in the right order. They wanted blue, then orange. That's symmetry property when you flip the order. Okay, so I'll do it again. Orange is the same thing as purple because they're both equal to green, right? That's substitution. And then I say that orange is the same thing as the blue because purple is the same thing as blue. So I took purple and switched out blue for it. Then I flip their order by saying symmetry property. Done. This one. I labeled all my angles with colors. I wrote down what we're given here. So here it is. 1 and 2 are supplementary. 3 and 4 are supplementary. 2 and 3 are the same. So I'm going to take those first two and just write out what they mean. 1 and 2 are sup means that they add up to 180. 3 and 4 are sup, so it means they add up to 180. That's the definition of supplementary, right? So if I know those equal 180 and those equal 180, then they equal each other by substitution. So I took this stuff and I plugged it in for 180 here because they're switch outable, right? You with me, Chance? Yeah. Okay. Then I'm going to switch 2 for 3 because they said I could, right? So I'm going to make that 3 a 2. Now when I subtract them from both sides, they go away and I get this. So I do subtraction property and I get here. And then I say, well, then that means they're congruent and I win because that's what they wanted me to find. Red and pink are the same. And they are. How do you feel? Nelly?
Great.
For real? Okay. This one's a weird one. Do you want to see it or no? Sure you do. All right. So we're going to prove that 1 and 2 are supplementary. Linear pair theorem says they are. Done. So what we're going to do is we need to prove that 1 and 4 are the same and 2 and 3 are the same. We're not allowed to use vertical angles, okay? We're proving vertical angles right now. So see how 1 and 2 are supplementary by linear pair? Okay? Well, so are 2 and 4. So 1 and 2 gets 180. 2 and 4 gets 180. Subtract 2 from both sides, and I get 1 is 4. Now I'm going to prove that 2 and 3 are the same. 2 and 4 are supplementary. 3 and 4 are supplementary. Subtract 4 from both sides. 2 and 3 equal each other. Yeah? Really? Damn. All right. Okay. All right. All right. All right. All right. This one. Define the terms. Transversal. A line that cuts two other lines, right? Okay. Corresponding angles. Two angles that are in the same spot. 1 and 5, right? Same relative location. If the lines are parallel, then those angles will be congruent. Same side interior on the same side. So these are same side, right? Interior here. 2 and 5. Or 3 and 8. Alternate exterior. Opposite sides of the transversal, right? And then on the exterior. So here's the exterior. Here's opposite sides. 1 and 7, 4 and 6. Now you might say, well, 1 and 4 are on opposite sides and they're on the exterior. So why don't they count? Because they're better called a linear pair, right? That's a linear pair. 1 and 7 are the better answer for alternate exterior. You also need to know same side exterior. Same side exterior, like 1 and 6, right? And alternate interior, 2 and 8, 3 and 5. Now you might say 5 and 8 are alternate interior because they're on opposite sides and they're in the interior, but they're better described as a linear pair, right? How do you feel? Okay, all right, all right. 22, page 22, I'm saying. Prove that angle 2 is equal to angle 7. Here's my logic. Having trouble seeing it, Chance?
No, I'm okay.
Okay, because if you want to move closer, you can.
I'm okay.
All right, so I need to prove 2 and 7 are the same. I'm going to say 2 and 3 are the same by vertical angles, and then I'm going to say 3 and 7 are the same by cap, which means 2 and 7 are the same by subs. I switched out 2 for 3. This one, again, right given L and M are parallel. That's important, right? 4 and 3 are supplementary by LPT, right? Linear pair theorem. Then I'm going to write that 3 and 7 are the same by cap. So that means 4 and 7 are supplementary. I'm going to switch out 7 for 3. That's by subs. This one says AFG, that's this angle, and DFE. Well, they're vertical, so they're both 50, right? You could do the rest of this, I think, pretty easily, right? This one right here is 145, so we do some math to figure out the rest of them. Vertical angles is what you're going to need, right? A little bit of linear pair. Next one. Given that PQ is parallel and MN is parallel, I know that 3 and 7 are the same by cap. 7 and 15 are the same by cap. So by substitution, 3 and 15 are the same. Prove that 10 is supplementary to 7. Here's how I do that. Here's 7. So I'm going to say 10 and 11 are supplementary. 11 the same thing as 15. 15 same thing as 7. So 7 and 10 will be supplementary by substitution. Okay. Next one. The key here is to notice that P and Q aren't parallel. So 10 and 14, even though they're corresponding, they are in the same right spot, right, the top right corner, they won't be congruent. But 10 and 2 will, because we have 2 parallels cut by a transversal. And 14 and 6 will, because we have 2 parallels cut by a transversal. 2 and 6 won't be, right? So we use that to fill out the rest. They tell you some angles up here, and you fill it out. Linear pair, vertical angles, get it done. Okay? This one. You ready for this? You ready?
Yeah.
Prove that angle 6 is 160. Here's what we're going to do. 1 and 5 are the same. So that tells me that this is 2y plus 8, right? So I'm saying 1 and 5 are the same by cap. 5 and 13 are the same by cap. Okay? I know 1 and 13 are the same, so I can make that 2y plus 8. I say these are supplementary, so they add up to 180. So that means 2y plus 8 plus 30y minus 20 equals 180. I solve for y. After I get y is 6, so I plug that in, and I get a number. And then I say these are the same by cap, which means 6 must be that. So, let me zoom out a little bit. Can't see that at all, can you? 1 and 5 by cap. 5 and 13 by cap. 1 and 13 by cap, or by substitution. Then I say that 13 and 14 are supplementary by linear pair, which means they add up to 180 by definition. 1 and 14 must add up to 180 by substitution. See how 13 and 14 are, and I can switch out 1 for 13? Okay. I plug in the values for 1 and 14, 2y plus 8, 30y minus 20 by substitution. Then I do math, and I find out y is 6. I say 6 and 14 are the same by cap, and I switch out 14 for its value, 30y minus 20. I plug in 6 by substitution, and I find out 6 is 160. It's a lot. It's a tough one. A lot of writing. How do you feel about the logic, though? Okay? It's tough. This one. These two angles are the same because corresponding angles, which means they're both 3x. These are supplementary by linear pair theorem. I solve for x, get a number. It's 14. Then I say if that's 14, then I know what this is. It's going to be 42. And then I can say these are supplementary. So they add to 180, and I solve for y. This one. These two angles are the same, corresponding. These are the same by vertical. So 5x minus 20 equals 3x. Solve, x is 10, so that means that's 30. Then I say these are a triangle, so they all have to add up to 180. And I solve for y. This one. Terrible line, ignore it. It should be like this. Okay? I cut this in half, and so I know these two angles are 62 because of vertical and corresponding. Then I know this part, these two angles are the same because of corresponding, and these are linear pairs, so they add up to 180, so that's how I got 36. Put them together by angle addition postulate, and I've got 98. Done. Hanging in there? Okay. What is slope? Rise over run. Change in y over change in x. y2 minus y1 over x2 minus x1. Vertical distance, because subtraction is distance. Y is vertical. Horizontal distance. X is horizontal, subtraction is distance. How to find slope. Instead of using slope formula, here's what I do. I'm starting at -2 for my y, and I'm moving to -1 for this y, right? So how much did I go up by? 1. I'm starting at 0, and I'm going to -2. I did -2 to get there, right? I subtracted 2. So my slope is 1 over -2, -1/2. Going from -3 to -4, I went down 1. Going from -1 to +1, I went up 2. So my slope is -1/2. Same slope, parallel. Could you plug that into slope formula, y2 minus y1 over x2 minus x1? Sure. But you might mess it up. Here, I think makes more sense. I'm on -2. I add 1 to get here. I'm on 0. I subtract 2 to get there. Better? Yeah.
Jordan said she's gonna be on the live thing in 2 minutes.
Oh, okay. Next, 7 going to 9, 2, right? 6 going to 6, 0. That's a vertical line that's undefined slope because we're going up 2 and over 0, right? We just keep going up. Same thing here. It ends up being 9 over 0. So they're both just going up, which means they're parallel. Same angle, right? Here, so the reverse, 0 on top, which means we're going up 0 and over 11. So up 0 over 11, we're talking horizontal line. Same thing here, so they're parallel. If this came out to be 2 versus -1/2, they'd be perpendicular. Because if you take this guy and negate him and flip him, you get 2, right? Flip it, we get 2 over 1, and negate it, we get +2, right? So if that was a 2, they'd be perpendicular, right? So we have parallel when they're the same, perpendicular when they flip and change the sign, and then askew is anything else that's random, right? Like if that was +1/2 and that was -1/2, they're just random slopes. Different, not the same, not perpendicular, so they're askew. What's confusing? Use slope formula if you don't like it. All right, this one. We want a line that's parallel to that, so same slope, right? I plug in the point, I find out what the equation is, it's this. Same slope, and I found the y-intercept, finding b. Remember that? I plug in those points, -4 for x, 6 for y. Then I graph it. 9 for the y-intercept, up 3 over 4. There's my line. Look, it does go through the right point. This was the line here. They're parallel. Trust me. Perpendicular. Same thing, except we don't use the same slope, right? We use flip and negate. So if I flip that, it's 3 over 1. And if I negate it, it's now positive, so it's +3. I plug in these points, and I find that b is -17. So instead of going down negative 17 and going up 3 over 1, which is off my chart, I plotted this point, and then I used my slope, up 3 over 1. Drew my line. This one, I drew my original line, y equals 6, and I want something that's perpendicular to that. Y equals 6 is this line because it's all the points where y is 6. I've got 0, 6, 1, 6, 2, 6, 3, 6, right? That's what y equals 6 means. I want it to go through 0, 0 and be perpendicular. So there's my line. What's the equation of that line? Where x is always 0. 0, 0, 0, 1, 0, 2, 0, 3. It's always 0 for x. This one, perpendicular to x equals 0. So it's this line to start out with. And I want perpendicular. So it's going to go this way, right? I want it to go through this point, negative 3, negative 1. So I drew it. And that's the equation where y is always negative 1. I've got negative 3, negative 1, negative 4, negative 1, 5, negative 1. It's always negative 1 for y. And now we're where we were recently for the review, for the test. Find their slope, right? Negative 2 over 1, negative 1 over 2, 0 over 8. Find their slope, and if they have the same slope, they're parallel. A and B are the same, so are V and C. So they're parallel. To find their magnitude, it's just Pythag, right? Negative 2 squared plus 1 squared. It's 4 and 1 added together is 5, so root 5. How do you feel about magnitude? Good? Yeah? All right. Translate by vector 6, negative 2. So we're going 6 to the right and 2 down is what it says. So our rule is add 6 and minus 2. That's it. Do it to your stuff. Feeling good about that? All right, all right. Same thing here. It's going to be 5 to the right, or 5 to the left and 8 down. So you're going to go this way. And your rule is minus 5, minus 8. Right? Okay. This one. Vector is negative 4, 3. We're going from here to here. 4 to the left and 3 up. Right? And then our magnitude is 4 squared and 3 squared added together. 5. 16 plus 9 is 25. Root it, we get 5. For real? 4 to the left. 3 up is our vector. We're going from A to A prime, right? Same thing for all of these. It'll be 4 to the left and 3 up. To find the magnitude, we square them. So square 4, square 3. Root them. Turns out to be perfect square. It's 5, right? Thank you upside down. That's impressive. How do you do that? Are you guys watching the stream?
No, I'm watching it in real life.
Wow. That's deep. Next one. Here it is. Graph the mirror. Y-intercept at 4, down 1 over 1, right? Graph the point. It's there. Find the perpendicular line. Flip and negate the slope, so positive 1, right? We flip it. Still 1, negate it. Now it's positive. Find B by plugging that in. It's negative 4. Then we set them equal. And solve for x. It's 4. Plug it back in and get y. Put that in the midpoint formula. Our midpoint is 4, 0. A is one of the points we know. And now I solve. Times 2, subtract 1. Times 2 is 8, minus 1 is 7. Times 2 is 0, add 3, 3. That's A prime. Right there. 7, 3. Yeah? Stuff you've recently done, right? Okay. This one, just setting it up, we'd flip and negate it, right? 1 over 3 turns to 3 over 1, and then we change the sign. How do we find B? Plug in the point, right? Okay? Then we set them equal. Find X, find Y, put them in midpoint formula, find the reflected point. Hey, look, it's a translation. We moved 8 down, so there's my rule. What kind of a flip did we do? Vertical, so we negated the Y. It's over the x-axis, right? What kind of flip did we do? Horizontal, so we negate the x. This one's more complicated. Because when we flip it, yeah, we negate the x because it's horizontal, right? But we need to adjust. So check it out. Ignore this. If I were to flip it normally, a is 2 away from this line, and it would put it here. See how far it is off where it's supposed to be? So I have to slide it 2 to the right. So the idea chance is that normally a is 3 away from our line of reflection. So when I flip it, it's still 3 away, right? But when I do the negative x rule, all it would really do is flip it across this line, right? So it would end up here, 2 away on each side. So to adjust for that, I send it 2 more to the right. And if you check, it makes sense. If I negate 2, I get positive 2. And then I add 2, I get 4. Okay? Another way to think of it, slide this to the right 1. Negate your x. Slide it back. And it simplifies to this when you distribute the negative. Pretty rad. Are you really with me? Okay. This one, 180 degrees centered at 0, 0. Super easy. Negative x, negative y, because we go from double positive to double negative. X and y don't trade spots because horizontal stays horizontal and vertical stays vertical. Right? There's the rule. So what I would do is I'd plug in all my coordinates here and then get them. Here, 90 degrees clockwise, ignore that. Rotating from here to here is clockwise, right? So my rule would be negate the second guy and flip the x and y. Why flip the x and y? Because horizontal becomes vertical and vertical becomes horizontal. There's the rule. Put in your coordinates here, do it to them, and then move, and then you'll get it. Don't try to do your L's. That'll be awful. If it was counterclockwise, we'd go this direction, which means we'd negate the first guy instead because it's negative positive. Right? X and y would still switch spots because horizontal becomes vertical, vertical becomes horizontal. This one, not centered at the origin. So first we slide it, 1, 1. 1 to the right, 1 up. Then we do our rule, negate the y and the x and flip them, right? Because we're doing 90-degree counterclockwise, right? Flip them and negate the first one because we're going counterclockwise. And then we undo what we did before. So I add 1 to my x and 1 to my y. I flip them and change the sign, and then I subtract 1 from each. Chance, are you with me? For real? This is tough stuff. Nelly? Okay. Can't even see half this stuff. Come on.
We had this on like the last quiz.
Yeah, we did, but you feel good about that?
Yeah.
Awesome. Okay. Most people did not finish. Because you guys got all disoriented.
It took me 3 hours, but I finished.
Mr. Mike, when is the study sessions on Monday?
On Monday? From 3 to 6, I think. And then there might be one from 6 to 9, but I'm not sure.
Okay.
I hope not.
Okay.
It's on Instagram.
Okay.
Ow. That did not help. All right. Next one. Slide at the origin, 1 to the left and 3 down. Then I flip and negate because I'm doing clockwise. So I'm going this way. So I negate the second, and I flip the x and the y because it's 90 degree. Then I add 1 and add 3. So notice when I flip, the y minus 3 and the x minus 1 both switch. And then I add 1, negate this, add 3. Questions on that? I would take those points and plug them in here and get these guys. Don't screw up your math. See how the parentheses go around the y minus 3 and the x minus 1 because you did that first? Make sure you don't throw that negative sign in early, okay? My videos are all blocked on the school accounts. Is it because I'm radical? I'm too cool for school. So sign out of your school accounts and watch them, right? What are you guys doing? Memes?
No, it's our friend from camp. Yeah. His name is Campbell. Campbell? Oh my gosh.
That's my paper that you threw.
Explain the rules. You guys know how to explain them, right?
Yes.
X and Y switch spots. Don't switch spots for 180 because we're still, what was horizontal here is still horizontal there. And vertical stays vertical. They just go opposite directions, so it's negate them both, right? For a 90-degree rotation, we're going this way. X and Y switch spots because what was horizontal becomes vertical now, and what was vertical becomes horizontal. And then we negate the first one if we're going counterclockwise and the second one if we're going clockwise because of direction. So if we go this direction, then we're here. And that's what those quadrants are, right? So we negate the second guy. If we go down this way, then we end up here. Still switching X and Y, but we negate this one because it's positive, negative. Okay? That's that quadrant. So explain that with words. Explain the rule for reflection over the x-axis and reflection over the y-axis. Well, if it's over the x-axis, that's this guy. We're going this way. Vertical flip, negate the y. Going this way, horizontal flip, negate the x. Rotation with an arbitrary point. Move the center to the origin with a vector, then do your rotation, then slide it back. That's the explanation. This one, for instance, move it to the center by -3, -2. 3 to the left and 2 down. Then negate both because they want us to do 180 degree, and then slide it back. You could put that rule together, I bet. Dilation centered at the origin. Super easy. You just do what it says there. Take those points, plug them in. Bam, done. That's it. Take those points, plug them in. Bam, done. Take those points, plug them in there. Bam, done. This one, to figure out the rule. It says centered at the origin, right? So all we have to do is figure out what happened going on here. Well, it was 3 across horizontally, and now it's 6 across. Oh, sorry. It was 6 across, now it's 3. What do? We went from 6 to 3. What do? Times it by half in the x direction. Not only that, but see how A and B switched spots? A was on the left, and now it's on the right. So we negated it. Flip this way, and then shrink, right? Keep the y the same. This one down here, I actually drew it right this time. So check it out. There's the center of dilation at 0, 0. We were 5 up and down, now we're 10 up and down, so we doubled it. Oh no. This is not right. I have 2 y's there. That's an x. So we went from 5 up and down to 10 up and down, so we doubled it. We went from 2 left to right to 10 left and right, so we times it by 5. 2 became 10, so we times it by 5. With me? D and B didn't change spots, so no negation. A stayed on top, C stayed on bottom, so no negation. Okay? Take those points, plug them in. All right, dilation, arbitrary center. Move it to the center. 1 to the right, 7 down. Double it and double it is what they want us to do. So that's the next thing we're going to do. Then we move it back. So what did I do? I did x plus 1 and y minus 7 in parentheses because I did that first, right? Then I doubled them both, 2 on the outside. Then I subtracted 1 and added 7. That's my rule. Take those points, write them down, plug them in, don't screw up your math, and get these guys for free, then plot them. Easiest way to do it. This one, it says third it and have it. That means after we move to the origin, which we're going to do by going 2 to the left and 1, 2, 3, 4, 5 down. Again, moving it to the origin, that's there. My arrow was a little bit off. Then we're going to have third it and have it. So we're going to third our x, have our y, and then we're going to move it back. So the rule would be x minus 2, y minus 5, put in brackets, right? Times a third, times a half, add 2, add 5. This one. Let's check it out. We move C to the origin, 2 to the right and 3 down. We times by negative a half and half over here. Why a negative a half? Because we went from 6 across to 3 across, right? That's half. The reason we use negative is because see how T was on the left and U was on the right? See how they switched spots? So we flipped it, didn't we? We flipped this guy across horizontally. So negative a half. Vertically, it stayed the same. V and U, V and U. So it's just a half. Went from 6 to 3. So there's my rule. Add 2 minus 3. Put in brackets. Negative a half, positive a half. Minus 2 plus 3. Doing good? All right, we're almost done, guys. That's exciting. This one, how would I do it? First, I'm going to flip it across so that U and V are in the right orientation. See how U and V are left to right up here? And when I'm done, they need to be, right? So I flip it. So U and V are in the right spots. Before they weren't. Then I stretch it to the right amount. I times it by 2 and times it by 5, which isn't only going to make it the right size, which makes it down here, right? But it's also going to push it away from the origin. So times 2 times 5 pushes it way down here and makes it the right size because it was 2 across and I need 4 across. So I times it by 2. I had 5 and I want 5. I had 1 and I want 5, so I times it by 5. What is that going to do to my coordinates? Well, it moves U to here, 8, negative 10, right there, after I do all that. And now I need to push it up to here because now it's the right size. And U and V are left to right instead of right to left. So I flipped it to get in the right order. I dilated it by doubling it and timesing it by 5 to get it the right size. And then I pushed it in the right spot. So notice U is at 8, negative 10. And I need it to be on 4, 6. So I subtract 4 from 8 to get 4. And I add 16 to negative 10 to get 6. And that'll push it in the right spot. What I'm doing is I'm doing a vector from here to here. And what I need to do is do negative 4, positive 16 to get there. 4 to the left and 16 up to get there. So I negated it to flip it. I times it by 2 and times it by 5 to stretch it. And then I found out where those coordinates were after I did that. And I pushed it in the right spot by using that vector. Explain a dilation by an arbitrary point. Push it to the center, dilate it, and then push it back. I spoke it, and I didn't write anything.
Oh, so that was probably a lot faster.
Yes, a lot faster.